Hi, my name is Aman Chowdhury.
My name is Mihir Shaker.
And my name is Mayank Shaker, and we are all students at the Medical Science Academy at Hightower High School.
To demonstrate our purpose, we're going to give you a challenge. The image shown above is a CT scan of a lung nodule. In a minute, we're going to flash a CT scan before your eyes, and we want you to count as many lung nodules as you can find. Ready? 3, 2, 1, go. I'm sure you counted a couple, but did you notice the gorilla at the top right of the scan? If you missed this, you're not alone. 83% of radiologists also miss this when they're given the same task. This plays on the example of a gorilla walking through the screen when we're trying to count basketballs. This goes to show that unintentional blindness paired with analyzing CT scans does not make for a good match. We need a better approach, and that is what our project aims to do.
We decided to specify our project on a type of neurological medical emergency called stroke, which is a disease of the nervous system. The main reason for choosing stroke was that it is one of the most commonly missed conditions, which is truly devastating considering that with proper diagnosis and subsequent treatment, the survival rate is over 80%.
So we got together to try and figure out how to improve the diagnosis of strokes. As high school students, our medical experience is limited. Therefore, we interviewed emergency care specialists and radiologists in an effort to better understand the barriers surrounding detection of strokes. We learned that despite best efforts, strokes are often missed because diagnosis is ultimately dependent on human ability to analyze scans in a timely manner. Time is crucial in this case, as in 1 second, 32,000 brain cells die. In a minute, 2 million. The impact of something as severe as an ischemic or hemorrhagic stroke is significant. This brought us to the question, would a machine-based approach be more efficient at diagnosing stroke?
We hypothesized that if an object detection model can be created for strokes, then the software will have a higher accuracy and speed than radiologists alone because it utilizes machine learning and solves for unintentional blindness and human error.
What is machine learning? The answer comes from the name. It is a form of artificial intelligence where a computer program devised to detect strokes on CT scans is able to learn from its own experiences. When we look around the world today, machine learning is present everywhere, from predicting weathers to recommending products to self-driving cars.
With a clear goal in mind, we then created a plan for how to accomplish our project. In order to succeed, we need to A. Collect training data, B. Create the program, and C. Test it to ensure it works properly and accurately. Our project did not require many materials. All we needed were up-to-date computers that could run the program and hundreds of different scans of both positive and negative cases of stroke.
To respect patient confidentiality, we obtained de-identified scans from Radiopedia, ResearchGate, Mayo Clinic, the Radiological Society of North America, and other published articles. We then analyzed each individual scan for stroke using knowledge we learned from specialists we interviewed and online sources. Once the scans were correctly labeled, we could now develop an algorithm for our machine learning program. We came up with a two-part program where the first component was to develop a visual detection model which analyzes CT images and translates this into a format understood computers. In the second component, we applied machine learning to study diagnose scans and find attributes for correctly identifying ruptured blood vessels. These two components complement each other to both learn the characteristic of stroke appearance on CT scans and apply this learned knowledge to future scans.
Now for the last part, testing the program. The two graphs show some important information about machine learning. Firstly, with each additional scan, the program is getting better and better at learning and now takes more information from each scan. But secondly, with each additional scan, the time it takes for the computer to understand what's going on and analyze the picture actually takes less and less time as well. Now, if you look at the next scans, they were chosen at random and show you an overall reflection of the program's capabilities. For improved reliance, the program also provides a confidence reading, telling us how sure it was of its decision. This also is crucial because it gives the radiologist assurance of the program's capabilities. Here, the program was accurate 93% of the time and had an average confidence reading of 78%. When we set out on this mission, we had a base criteria for an 80% success rate. From our research, we found that this was sufficient to prove the program's capabilities, and further accuracy could be gained over time and with more data.
The broad application that the results and data have shown us is that machine learning software used in identifying CT scans can save millions of lives through averting misdiagnosis and early treatment. Considering that over 800,000 people suffer from strokes every year, we see the true potential of our software to save lives through accurate diagnoses. With the base model now created, we would like to expand the use of our machine learning software to other forms of imaging, such as MRI and PET scans, and thus apply our technology for accurate detection of other strokes and neurological diseases.
Thank you for listening to our project.